So here's just an overview of what I'm going to be covering tonight. I'm going to be talking about synesthesia, and I think you'll find that I'll fluctuate between the British spelling and the North American spelling, so apologies about that, go back and forth. So what is synesthesia? And I'll talk a bit about its neurological basis, so its basis in the brain. I'll also talk about its range of variants, because it's not one condition, it's many conditions. And then I'll talk about links with normal perception. Okay, so I'm not suggesting that synesthetes are not normal, but I'm suggesting that there's also a general population, so we use the word normal in a statistical sense, of the rest of the population we can also consider, because there are links between synesthesia and the rest of us as well, and I'll talk about that at the end of this talk. My definition of synesthesia: it is a rare inherited condition, and it causes a merging of the senses. So this is just an easy way to describe what it is. And what I'm going to do is just tell you what it is just with a few examples, because there are many kinds of synesthesia. So let's start with this example here. So if you're a grapheme color synesthete, you could just maybe see those colors of letters in your mind's eye. Or maybe you might just know the colors of letters. So for example, you might know that A is red, or that B is blue, for example, or that C is green, and you don't have to necessarily see them anywhere. What makes you a grapheme color synesthete is having those one-on-one associations, a letter to a color or a digit to a color, and that's grapheme color synesthesia. Just another variant of synesthesia, just to get us rolling so that we understand what we're talking about. This chap here is James Wannerton, and James is the president of the UK Synesthesia Association, and James tastes words. So James has lexical gustatory synesthesia. So hearing words, or reading words, or thinking about words, floods his mouth with a sensation of taste. Each word has its own taste. So my name, Julia, tastes of fruit sweets, not just any fruit sweets, a taste of these fruit sweets. These are Starbursts. I don't know if you guys have these. Not just any Starburst, a taste of the orange ones. Okay? So when he hears my name, Julia, his mouth floods with the sensation of this taste experience. And James is a very, very nice chap, and one of the first questions anybody wants to know from him is, what does my name taste of? And he's very polite about it. So I've seen him over the years slightly hesitate for half a second, and it's almost imperceptible, but I know that means that this person's name tastes bad. And for the longest time, James told me that I knew that Julia tasted of fruit sweets, but everybody calls me Jules. He doesn't, he calls me Julia, and he's very kind, and for 10 years, he told me that it had the same taste, just a bit too intense. And he told me maybe 6 weeks ago, after knowing him for a decade, turns out that Julia tastes of wallpaper paste mixed with porridge. Jules tastes of wallpaper paste mixed with porridge. So that's why he doesn't call me Jules. He calls me Julia because it's very pleasant and he likes the taste of it. So here's just a third kind of synesthesia, just so we know what we're talking about again. This is what we might call taste-shape synesthesia. So this synesthesia is triggered by real food in the mouth, real food. And the experience, the synesthetic experience, is a sensation of touch or shape against the fingertips, sometimes the back of the arm and up against the cheek. So this kind of synesthesia was brought to public consciousness by Richard Synesthesia, who really is responsible for regenerating the field of synesthesia research. And all of this research that Richard did could be traced back to one night, I think in about 1979, when Richard went for dinner with his neighbour, Michael Watson, and his neighbour was cooking dinner and muttering and apologising because there weren't enough points on the chicken. And Richard asked him what he meant, and Michael said that he has these shape associations for taste, and a really, really well-cooked chicken is all pointy. And his chicken that night, just all the edges were round. It was just all wrong, and so he knew that it wasn't very good. Now, Michael Watson happened to say that to precisely the right person, because Richard Synesthesia was a neurologist, and he had somewhere at the back of his mind heard of this term synesthesia, and that was wonderful for the field of synesthesia research. It wasn't so good for Michael Watson, the neighbour, because Richard went on to study him for about 19 years, I think. So, but luckily for us, we now know a lot about this form of synesthesia. So taste in the mouth triggers sensations of shape or touch. Right, so now that you know what we're talking about, I just want to readdress some of the assumptions that I've made already. I've said that this is a rare condition. I've said that it's an inherited condition. So let's talk a bit about that now. So we've always suspected that this was an inherited condition because you can see the way it's passed down through families, and it kind of looks like a gene-linked inheritance. So in 2005, we looked through the family trees of 85 synesthetic families, and we saw, for example, that we saw patterns that were suggestive of genetic inheritance. And then fast forward 4, 5, 6 years, Julian Asher and Steffi Thompson have now identified the chromosomes on which the genes for synesthesia are likely to lie. Okay, so they've basically identified the hotspot chromosomes that are carrying the genes for synesthesia, and so it's almost certain now that synesthesia is definitely inherited. So I've also said that it's a rare condition. For a long time, the prevalence of synesthesia wasn't really known. We tried to find out in 2006 by individually assessing a very large section of, well, very large, 2,000 people. We individually assessed 2,000 people, and every person we individually tested for synesthesia. And we found that the prevalence of synesthesia was a lot higher than we expected. We were extremely conservative in that study. We definitely didn't count someone as a synesthete if they weren't. But even though we were very conservative, we still found that it was 4.4, at least 4.4% of the population have synesthesia. That sounds like a little bit, but actually that's 1 in 23 people. So that means in a room this size, we would expect, I did the maths, we would expect 1.5 synesthetes in this room. And I'm so confident of this statistic that I will take every single person in this room out for a beer if I'm wrong and there are no synesthetes here. And I'm cheating as well. I'm cheating for loads of reasons. I cheat a lot. Okay, I'm cheating because this is a talk about synesthesia. So there are going to be lots more synesthetes here than in the general population. Right? But I can pretty much guarantee you that if you'd been passing and I'd say, come in here, I'll give you 50 quid, come in here, and if I individually assessed every one of you, even randomly, even if you hadn't come here specifically to learn about synesthesia, 1 in 23 of you would have, at least 1 in 23 of you would have synesthesia. So, depending on how you feel, sometimes I think that's a big number, and sometimes I think that's a small number. But when I work out that actually that's 307 million synesthetes worldwide, which is the population, around more than the population of the United States, this is not an insignificant condition. This is a condition which is a little baffling if you don't experience it, which has been on the periphery for a little bit, but actually it's really, yeah, it's significant. It's an important condition to study, I would say, but then I'm biased. So, if you've never heard of synesthesia before, and if you don't have synesthesia, then I probably think that you may have been not believing some of the things I've told you so far. Because synesthesia is a very challenging condition. It challenges our concept of reality. And that means that if you don't have synesthesia, it's very hard to believe that these experiences are actually happening. Okay? So most of us tend to think that the senses, the tastes and smells and touches and sounds of the world exist out there in the world, and that our apparatus is here just to pick up that information. But actually, we've known for a very long time that taste and touch and colour and smell, they actually exist in the human brain. That's where those perceptions exist. What I mean by that is that if I prod your brain in exactly the right place, you'll smell something. If I prod it in a different place, you'll see something. You'll see a coloured light, or you might smell burnt toast, which is a very famous example. And we know this because a Canadian, actually, I think, Wilder Penfield, a Canadian chap, was doing exactly this in around the 30s and 40s. He was operating on people for epilepsy and prodding their brains when he got the moment. And these people were awake because of the nature of the surgery, and they were reporting, oh, I just smelt burnt toast, because he was prodding in exactly the right place in the brain. So the point I'm trying to make is that synesthesia is that reality is not fixed. It's not a fixed construct. It's filtered through the individuality of our brains. And because some people's brains differ in teeny tiny ways, their sense of reality is different as well. And that's what we find in synesthesia. We find that synesthetes' brains are very slightly different to the average person. So I'm going to show you this right now, just in a very simple way, just the neurological basis of synesthesia. So what you're seeing here, if you can make this out, this is a brain. In fact, this is the brain of about 10 synesthetes all merged into one. And they all have this grapheme colour synesthesia. They have coloured letters and digits. Okay? And what's happening at the moment that this image is taken is that they're just in the scanner and they're looking at black and white text. They're looking at black and white letters. Okay? Right, so what I want to point out in particular for you here, so we're looking at the underside of the brain. This is the back of the brain, and this is the front of the brain. And I want you to see these two areas in pink. Okay? These two areas in pink are painted on in Photoshop to show you whereabouts the colour region of the brain is. So this area is called HV4, human V4, and it's the part of your brain that fires when you see colours. So my V4 is just activating away because I can see all of the colours in the room. Now, at the moment that this image is taken, there are no colours in the environment. The synesthete is just looking at black and white text. But what I want you to see is that here in the left side in V4, in the colour selective region, there's loads of activation. That red means that that part of the brain is really functioning, it's really working, even though there are no colours in the environment. So what this is showing us is that the colour parts of the brain are working when these synesthetes are looking at letters. This is effectively indisputable evidence for colour sensations in this population. So even if you've believed nothing I've said until now, you can believe this because you can't fake this kind of data. Why is the brain of synesthetes, why is it acting like that? Well, it's acting like that because it's structurally different. Structurally different. So what this scan shows is the same kind of synesthete. And again, this is the back of the brain, this is the front of the brain. And now these two patches of colour here are showing areas in the synesthetes' brains that are hyperconnected, that have extra bundles of white matter connectivity. You can think of white matter as being the wiring in the brain. So put simply, this figure shows us that synesthetes have this extra connectivity, extra wiring, in just about the parts of the brain that you would expect, near to the colour regions. And there's also another difference in the brains of synesthetes. Not only have they got more white matter connections, they've also got thicker grey matter. So grey matter is kind of like the cell bodies in the brain, and you can measure the thickness. And synesthetes have pockets of thicker grey matter in the brain, and you can see here's a little pocket here. Again, you can see it from this is the back of the brain, so again, similar sort of regions. So, why is this happening? What's causing these differences? So the short answer to that is that we don't know yet, but we have a really, really good hypothesis. And I say we, I don't mean me. I mean, Daphne Maurer and her colleagues have come up with what I think is probably the most impactful and important theoretical model of how synesthesia might develop. And I'm going to talk you through it now, okay, because there's lots going on this graph. So this theory is called the neonatal synesthesia hypothesis. And it's based on the fact that if you look at the brains of all of us as very young children, we all, as babies, have very hyperconnected brains with really thick grey matter. The infantile brain looks a lot like a synesthete's brain, and so there's a very real reason to believe that all of us may experience synesthesia at a very young age. Okay? So what happens in the average person, like me, the average impoverished non-synesthete, is that we grow up. And as we grow up, the thickness in our brain thins out and the connections get cut away. And that's what this is showing here. So this is just the brain of an average child from the age of 4 to the age of 21 years. As it gets bluer, that means the grey matter is getting thinner and thinner and thinner. So as a very young baby, there's loads of thick grey matter. And as an adult, that's all thinned away. The suggestion is that synesthetes are not undergoing that same thinning or pruning process, that they're retaining this extra connectivity and this extra thick white matter all the way into adulthood. And I think this is a very elegant theory, and I'm absolutely, the more I test, the more persuaded I become of this theory here. So that's maybe what's going on there. Okay, so let's come away from brains, in case you don't like to see too many brains, and let's talk a bit more about the impact of synesthesia. And I wanted to talk a bit about creativity being in, this building here. It was such a pleasure walking along the corridors and hearing all the music and all of these creative individuals coming together. And I was thinking, synesthetes are themselves a bunch of quite creative people. So one thing that we know is that if you give a synesthete a test of creativity, in some tests at least, they're going to perform better than the average person. Okay? And we need to be careful when we talk about tests of creativity. We need a scientific way to measure creativity, and there are a couple of these tests. So I'll show you these tests now. Here's a test of creativity that has been run by Catherine Morvenna and Jamie Ward and their colleagues on synesthetes. So what you probably can't see at the bottom here are 3 words, and the words are boot, summer, and ground. And this is called the remote associates test. And your task is to come up with one word that links all three of these words, boot, summer, ground? Okay, and just as I was doing that, I heard the answer from my stooge in the audience, potentially. It's camp. Okay, so you can have a boot camp, you can have a summer camp, and you can have a campground. So that's one word, the remote associates. And when you do this as a hard test, I never get these right. I'm not very good at this test. If you give this to synesthetes, they're very good at this test, and they're better than the average person. Right, here's another test of creativity that I find easier to explain. So this is called the alternative uses task. This is easy. I just give you an object and tell you to give me as many alternative uses for that object as you can. So give me as many uses for a brick as possible. Paperweight. Doorstop. Does it have holes in it? It can do, so long as it's still a brick.
Bookcase.
Pardon?
Part of a bookcase.
Part of a bookcase. And what was your?
Weapon.
Weapon, okay. Did you have a holy one? No. All right, so when you ask the average person, you tend to get three responses. You can build with it, you can build something crazy with it, you can stand on it, look over a fence, or you can throw it through a window. They tend to be the three categories that you get. And when you ask synesthetes, you get a different kind of reply. You get many more suggestions and more disparate suggestions, so you end up with things like this. Okay? So when we assess synesthetes for tasks of creativity, they perform better. Now, the reason for this isn't quite clear. It may be that whatever is the extra connectivity causing synesthesia is also able to cause these extra abilities in creativity, for example. And that means that many synesthetes end up working in the arts. So if you're a synesthete, you're significantly more likely to work in the arts. And this is just one of my favorite synesthetic paintings by Carol Steen. This is called Clouds Rise Up. This is Carol's synesthetic experience when she heard a Japanese flute once, and she painted it, and I think it's beautiful. And this is quite typical of the kind of creative output of synesthetes. Right. So I'm going to spend really the majority of this talk just talking about different variants of synesthesia very quickly, and giving you, telling you really that although the variants of synesthesia can differ, they do have these shared characteristics, these things in common. Okay? And in particular, what I want to persuade you of is that the associations for synesthetes, so the association between a letter and a colour, for example, that they're not random associations, that actually synesthetes are using quite sophisticated rule systems to work out what kind of sound goes with what kind of colour and what kind of taste goes with what kind of shape. They don't know these at a conscious level, but if you look very carefully at the synesthesia, you can find all of these lovely rules operating, and that's what I'm going to tell you about now. What I've shown on the board here are the coloured alphabets of two of my synesthete participants, RF and AP. And what I want you to see is that they're different to each other, right? So, and this is very typical. When you get two synesthetes together, they'll often disagree on their colours. So RF would say, I can't believe you think A is yellow, of course it's red. And then AP would say, well, you know, you've got the colour of H all wrong anyway, or J all wrong, and so on. So getting two synesthetes together, you'll get lots of disagreements. And I randomly picked these two synesthetes, and I counted the matches, and there are 6 matches out of 26 letters. Not a lot of matches, okay? And so for a long time, for maybe 150 years, this led researchers to think that synesthetic associations are idiosyncratic, and also that they're pretty random. So in 2005, we wanted to look not just at two synesthetes. We wanted to look at a large number of synesthetes to see what was really going on, and we looked at 70 synesthetes. And in 2005, that was quite a feat, actually. We can do that now. We can look at thousands of synesthetes if we want to, kind of. But in 2005 or 2006, we were able to get 70 synesthetes, and every single synesthete, we said, what's your colour for A? What's your colour for B? And we elicited those colours. And then we looked at every letter to see whether there were any patterns. And we found that there were patterns. We found that although the letter A can be any colour at all, it's significantly likely to be red above all other colours. Okay? And B is likely to be blue, and C is likely to, and I apologise if you're a synesthete in the audience, you might not like any of this, but one thing I can tell you is that there is something to this prototypical synesthetic alphabet, because I've never met a synesthete whose colours I can't guess. So normally if I find out that someone's a grapheme colour synesthete, I will pick, the prototypical alphabet is actually a little more like this. So some of these letters have more than one colour. All right, so B is likely to be brown or blue, and O is likely to be black or white or transparent or both of those colours. And so if I meet a synesthete, I'll usually pick on the O because that's quite a robust one. I would guess that your O is very, very light or very, very dark. Sometimes it's shiny and transparent. Also, the I tends to be the same colour as the O, and the I also tends to be the same colour as the number 1. What else? A, red, very, very common. Very common for A to be red. Doesn't have to be, but it's most common of all. So the point I'm making here is that there are these rules. So the point I'm making here at this point in the talk is that there are these shared associations. And then we wanted to know why. Why is A red? Why is S yellow? Why is S yellow? Why is X black? And so on. So we basically ran statistical analyses to look at the patterns that there were, and we found a couple of rules governing this system. And so we found that letters that are more common, like A's and E's and S, they're common letters, those letters are more likely to pair with the common colours. Right, so that means that A is likely to be red, whereas some uncommon letter like Q is likely to be purple or turquoise. Okay? And that is a significant finding. We also found, or in fact a colleague this time found, that more common letters are also more vibrant in colour. Okay, so A is a lovely bright red, whereas U might be some kind of duller colour, maybe a grey or something. And we also found a very slight tendency for colours to pair with their initial letter. So what I mean by that is that B's tend to be blue, R's tend to be red, G's tend to be green, and so on. Now that's actually a very subtle effect. If you get any one synesthete, you never find that all the way through. It's never the case, well, it's very rarely the case that they have the red R and the G green and the B blue and so on. But if you look at enough synesthetes, you can find that as a statistical trend going on in there, okay? And when I'm calling these rules, I'm not saying that synesthetes are following these at any conscious level. They're not. Quite often they can't verbalise why any of these colours are as they are, but we know these rules are going on. Okay, so let's jump onto another form of synesthesia, and I'll show you again that there are these rules in operation. This is a very, very, very common form of synesthesia. So it's called sequence space synesthesia. It's triggered by sequences, like letters, they come in a sequence, right? Numbers, they come in a sequence, yeah? Days of the week, that's a sequence. Months of the year, that's a sequence. So this form of synesthesia is triggered by those sequences. And the experience is not a colour necessarily, but it's a spatial layout. So for example, it's very common to have the months of the year in a running track shape in front of the body. So you can point, here's August, and I'm standing behind December, and oh look, March is a lot bigger than the rest of the months, and so on. Okay, it's very common. It's a very common form. It's, I think, the most common form. So I've got some examples here, and what I want you to do, just ignore the colours. You don't have to have colours for this form of synesthesia. What counts is the spatial layout. Okay, so this is a PD, and she has the months of the year in a running track, actually running around her body. This is IB. He has the days of the week. They happen to be coloured, but what I'm pointing out is that they're also in a particular spatial arrangement. And he's very, very particular about this. So notice that Saturday is not quite above Wednesday. It's very important. It's not quite above Wednesday, okay, but it's there out in space. And this is him as well. This is IB. And this is his centuries, years in a century. And they form columns coming up towards his body. So, for example, 1601 is at arm's length. Moving up to 1699, 1701 starts again at arm's length, 1799, 1801 down here, and they come up towards him, and he can see them. You can see them laid out in space. And I'll tell you something funny about IB. So in about 2000 or 2001, IB realised that 2001 hadn't gone back to arm's length. It was still coming towards him. And now he has to turn his head to look at 2014. And I said, and he's very surprised by this. He feels that this is something that happened to him. He doesn't feel that he planned this in any way. And in fact, whenever I ask IB the question why, he always says the same thing. He always says, I don't make the rules. Okay, so it just happens to him. My prediction, by the way, would be that it's going to curve around, so it'll keep within his eye line. So I'm watching IB. I'm watching him. Okay. So there are rules here as well. Okay. We can see these rules if we look at historical documents showing this form of synesthesia. So in 1880, Francis Galton, who's a prominent scientist in that time, wrote an article in Nature about visualized numbers, visualized sequences. And one thing that's very interesting when you look at his examples is this. Let's see if you can see it. You can see it? Yeah, okay. Something very prominent in these 19th century timeline, these 19th century number lines, 19th century synesthetic forms, is the number 12. And you can see that all of these forms, they bend at the number 12. These are all different synesthetes. This is THW, and this is their form. This is synesthete C. This is his or her form. And you see the number 12 really prominently in all of these layouts. And I would suggest, or it has been suggested, I think Jamie Ward suggested this first of all, that that's because at this point our monetary system in the United Kingdom was based on base 12. Okay? In 1971, it switched to base 10, okay? And we started to have more like a cent system. Yeah? And if you look at contemporary spatial forms, you see now that those bends are happening at 10. Okay? So there's a rule here. The rule is basically, it's an environmental effect. Whatever is a prominent number in the environment becomes a prominent number within the synesthesia, and you can see that change over time. Moving quickly on, I want to talk a bit about word taste synesthesia, which is something I mentioned before. And I want to again tell you that it's rule-driven, so I'll just remind you what it is. This is James Wannerton, and James has floods of taste in his mouth when he hears words, and different words have different tastes. And this is, so listening to words, this is a scan that we took of James's brain, and this is what James's brain looks like when he's hearing words. And what I'm pointing out is an area of particular unusual activation in James's brain, and that's in a part of the brain in the gustatory cortex, in the taste part of the brain. So hearing words makes James' taste cortex fire. Okay, so again, this is nice evidence of genuineness. But I want to tell you about James, prevalence. It's a very uncommon form of synesthesia. Very, very uncommon. So we don't even know how uncommon it is. We know that it is less than 0.02% of the population. It could be even less. We know that if you randomly select 500 people, you won't find a case of this. Okay? So it's less than 0.02%. And I was curious about how uncommon that is, because I know it's rare, but I didn't know how to kind of conceptualize it. So I Googled to find what things are common at 0.02% in the population. So it turns out that it is less common than having this condition, which gives you differently colored eyes. Okay, it's less common than this. Apparently it's less common than having an IQ greater than 176. So you're more likely, I didn't know who would have that IQ, so I picked Yoda, but apparently you're more likely to have an IQ of 176 than to have this form of synesthesia. And then a bit disturbingly, I found out that you're more likely to wake up on an operating table in the middle of an operation than have this form of synesthesia. So this is a very rare experience. That was just a segue. But it's not unknown. So in 2006, on American Thanksgiving, the New York Times described some of my research in this article called "For Rare Few Tastes, Taste is in the Ear of the Beholder." So it turns out that the world and his wife reads the New York Times on Thanksgiving, and within 2 days I had 56 people contact me who taste words. So it's rare, but it's not negligible, again. Oh, and some of those people are just some examples so that you know they're real people. I guess this is JG, and JG has taste for words, tasty words, and again has taste for all kinds of different words. I'm just going to give you an example of one word from this synesthete. So the word part, taste of chicken noodle soup, Heinz brand. For CS, the name Adrian, taste of salad with a dressing, Caesar salad dressing, too much garlic. DMS, the word protractor, taste of oatmeal, bowl of oatmeal. And for BL, who's another synesthete, the word moment, taste of a doughy bagel. JB, the word satire, taste of licorice. So we would want to know, why does it taste like this? Is this random, or is there some rule in operation here? Is it random? So one thing we did was look at the kind of tastes that are being generated in the synesthesia. And we gave JIW over 1,000 words, and he told us the taste associations. Okay? And then we classified the kinds of tastes he was having by their kind, by their category. And what we found out is that you don't just get random, all kinds of tastes from all kinds of categories. There's actually what we'd call a non-random search space, so some tastes are overrepresented. So it turns out that the most common tastes he has are of sweets and chocolate, candy, right? Then the next one is meats, vegetables, fruit, bread and cereal, dairy products, drinks. This one here, this light lilac that my pointer is not staying on, synthetic inedibles, so plastics, okay, for example. And this red one here, really not great taste. These are organic inedibles. These are things that you absolutely don't want in your mouth. Earwax, mucus, vomit, and luckily just a small portion of those. And the yellow ones are the ones that drive JIW crazy because he doesn't know what they are. So he would spend his life going, what is that taste? And yeah, very weirdly, for the first time, I understood that about 12 hours ago. So I landed in Canada, and I used to live in Canada, so I'm used to landing at the airport. And I used to think that Canada smelt of butter toffee popcorn. So I would land, and Canada would smell of toffee popcorn. And then I realized, actually, it's not. It actually smells of maple syrup pancakes. I realized that this morning over breakfast. And sometimes JIW does this. He will have a taste in his mouth. He'll either not know what it is, or he'll make a guess at it. And then many years later, he'll go, oh, that's what it is. And I had one of those moments this morning over breakfast, funnily enough. So why does it taste like that? We were able to show that it's not random, that actually these tastes are dictated by his experiences, his real-world taste experiences. So we gave JIW a dietary questionnaire, and we found that there's a significant association between the foods he eats most often and the foods that turn up most often in his synesthesia. So it turns out James eats all the time. He really likes minced beef and gravy, and he eats that a lot in his diet. And as a result, I would suggest, his synesthesia, it's a very prominent taste in his synesthesia. Lots of words taste of gravy and beef, minced beef. But the really interesting thing is that you really start to understand this condition when you look at James when he was a kid. This is James when he was little. We also gave his mother a dietary questionnaire asking her about the foods that she fed James when he was a child. And we found out that although the synesthesia is linked to his adult diet, it's significantly more linked to his childhood diet. Very strong association to the foods he had when he was a kid. And this is probably why there's so much candy and chocolate and sweets in his diet, in his synesthesia from his diet. Okay, so last one, probably my favorite kind of synesthesia, sequence personality synesthesia. And for this form of synesthesia, also triggered by sequences, letters, days of the week, numbers, things that come in sequences. But instead of having colors, the synesthete experiences personality types, like a personality. So here's an example. This is a synesthete we tested in 2007. For her, D is male. He's single, he's out on his own, he seeks advice from E and F. F is untrustworthy and has some very dubious connections. G is a middle-aged woman, she's best friends with H, and they get together and they gossip about D. Okay? And she has these, I've just taken a snippet of her description. She has very, very in-depth personalities for all of the alphabet, and this again is not new. So here is a paper, a book actually, written in 1893, Flournoy, a Swiss psychologist, describing exactly the same phenomenon. And I like this example here. This is a synesthete, and for her, this was written in French but translated into English. 1, 2, 3 are children who play together. 4 is a good, peaceful woman absorbed by down-to-earth occupations. 5 is a young man, ordinary and common in his taste. 6 is a young man too. He's very well brought up and he's polite. 7 is a bad sort, extravagant. 8 is a very dignified lady who acts appropriately, and this is my favorite. 9 is the husband of Madame 8. He is self-centered, maniacal, selfish. He thinks only about himself. He's grumpy. He's endlessly reproaching his wife for one thing or another, telling her that he would have been much better to have married a 9 because between them they would have made 18 as opposed to only 17 with her. So I've used this example because it shows you about the complexity of these associations. So we wanted to know, again, as a neurological basis. So we've recently scanned 12 individuals with sequence personality synesthesia, and what you find, this is a connectivity, this is the white matter, what you find are these extra bundles of connections in areas of the brain responsible for social processing and emotionality. Okay, extra connectivity in that region. So to fit the theme here, we wanted to know if these were random associations or whether you could somehow predict what personality any letter was going to get. So can you predict, knowing something about the letter, what its personality would be like? And the answer is yes, you can. So in order to do this, we needed a really detailed assessment of all of these personalities. So we turned to personality questionnaires, which exist. So anybody can fill out a personality questionnaire. I could fill one out, and it would give me a very detailed description of what I'm like in terms of the 5 traits of personality, which are, and I always forget, openness to experience, conscientiousness, extroversion, agreeableness, and neuroticism. Okay? So what we did is we took those personality questionnaires and we gave them to the synesthetes to describe their letters. So we gave them 40 adjectives, and this is what a personality questionnaire is like. You give all of these adjectives, and you have to rate how true this is, and the synesthete would rate how true. So how bashful is J? And they would say maybe only a 2 out of 5. How bold is J? How careless is J? How cold is J? And so on for 40 of these adjectives. And then we'd move on to the next letter, and the synesthete would do this for every single letter in their alphabet and give us a very detailed understanding of the personality of these letters. And then we just compared that personality with the frequency of the letter, with how common that letter is in English. Okay? And what we found was that there is a significant relationship in 2 of these factors. So you don't really have to understand this graph, but what it's showing you is that as the letter gets more common, the neuroticism goes down. Okay? And as the letter gets more common, its agreeableness goes up. So what that means is that uncommon letters, like J, are very neurotic and disagreeable. And the more common letters, like S and A, are the opposite. They are high agreeable and low neurotic. Now, this is definitely not something that the synesthete is aware of constructing. It would be bizarre to imagine somebody constructing this system. This is going on subconsciously without the synesthete being aware, but still, again, it's rule-based. Okay, so I'm going to end just by talking about the fact that whether you're a synesthete or not, we all have these cross-sensory experiences. And this last part of the talk is about the synesthesia that exists in all of us. Even non-synesthetes have cross-sensory associations between colour and sound. What I've shown you here is actually the colours of a real synesthete. And what they've done is Jamie Ward and his colleagues played them a note, and the synesthete just gave their colour associations for each note as it went higher on the scale. And what I want you to see is that those very high notes are lighter in colour than the darker notes, right? For this synesthete, and for all synesthetes, it tends to be that way, or a trend at least. And the point I want to convince you of is that all of us share that same cross-sensory intuition. All of us have an association between high pitch and light colour, and low pitch and dark colour. So what I've got here is I've got 2 sides of a screen here. One's very dark, one's very light. I'm going to play you 2 sounds, and I just want you to decide which sound fits best on each side of this screen. And I know that this is not going to work, but luckily I've got a piano, so I'm going to do it here. So most people feel that the highest notes somehow feel better on the right-hand side of the screen, that there's some kind of association between a high-pitched note and lightness, and a low-pitched note and darkness. And that's something that we all share. So we all have this cross-sensory association that's similar to the synesthete. It's just the synesthete is seeing that. Okay? It's like an extreme manifestation of what the intuition that we all share. And this is not just limited to sound and colour. We find it throughout the senses. So we recently did a study where we gave our participants a sugar cube, a sugar sphere. Okay. And the task was, eat the sphere and just tell us how sweet is it, how bitter is it, and how sour is it. And actually we made this out of a kind of lemony icing sugar, so it was a complex taste. And half of the people got a sugar sphere that had a smooth surface. And the other half of the people, unbeknownst, because nobody knew what was going on, they got a sugar sphere with a rough surface. And when we looked at their ratings of the taste, we found that they rated the rough one as tasting significantly more sour, as having a less sweet taste than the smooth one. Because all of us have an association between taste and touch as well. And again, it's not just limited to taste and touch. We also get it with taste and sound. So here's a study we did. We do some odd things to people. So in this study here, we got participants in the lab, average people from the student population, and we dropped a taste on the tongue. Okay, we used this dropper here, and we had these chemicals, and one tastes sour, one tastes bitter, one tastes sweet, and one tastes salty. And the task for the participant was to experience the taste and then adjust an on-screen slider which was playing a sound. Okay? And they just had to do it until they felt the sound match the taste in their mouth. And when we ask people to do this, they think it's a ridiculous question. They think they're answering randomly, and they're not. They're answering very systematically, because we found that when they're adjusting the slider, they gave the very, very highest pitch sounds to sourness, and that when you went from sweet to salty to bitter and to sour, the pitch systematically increased. Okay? We didn't give them these products. This is just here to show you what the tastes were like. We did it in a way that they couldn't guess what this object was, really. And again, we can find it in the colour of touch. So in this task here, we took about 200 people aged between about 7 and 88 across the population, and we had them put their hand through a screen. And the task was to feel the object on the other side of the screen and choose the colour that you like best with that object. And there were 18 objects that they felt one by one, and they felt an object, they chose a colour. They felt another object, they chose another colour. And unbeknownst to them, that we were giving them 3 kinds of objects. We were giving them surfaces which range from smooth to rough. 6 surfaces. One was very smooth, one was a bit smooth, one was a bit rough, very, very, very rough. And we gave them 6 objects that moved systematically from rounded to pointed. And we gave, you can't see what this is, but we also gave them blocks that ranged from hard to soft. Okay? And when we asked people to do this, they really thought it was the most bonkers task ever, and they thought they were being random, but they were being very, very non-random. Okay, I'm not going to expect you to make sense of this, but anybody who knows about correlations knows that there's a strong effect going on here. And what we found was that when the object got smoother or softer or rounder, the colour that they chose got lighter and lighter and lighter in a very systematic way. And equally, it didn't just get lighter, it also got more vibrant, it got more saturated in colour as well. So again, people are answering not randomly at all, but thinking that it might be random, but it's not. So all of us have these non-random associations. They're kind of similar to what synesthetes experience, but they're just at an intuitive level, really. And so just to summarise the talk tonight, so I've described synesthesia, which I wanted you to know is a multivariant condition. It's just not just one condition. It has a neurological basis, it has a genetic basis, and it has quite a complex rule system when you look at it in detail. It's not random at all. And that really there are these cross sensations in all people that can kind of mirror what synesthetes are experiencing. And I just wanted to end with a question that was posed to me by Peter Walker at Lancaster University. He asked me whether lemons were fast or slow. So I'm going to give you 5 seconds to decide. Fast. I'm not entirely sure why, but it's fast. So thank you very much. Thanks a lot. And thank you to my students, my lab, and my funders. Thank you.